Okay, hey, so this video is going to go over some different ways to solve an exponential equation. So when we're talking about an exponential equation here, we're talking about always have your exponential, so you have some base to an exponent, and inside of that exponent is where you're going to find the variable that you're trying to solve for. So you have some other things that are on the same side of the equation with the exponential. So as always, your first step is to isolate that using SADMEP. If you haven't heard of SADMEP, it is the backwards order of operations, and that is the process we use in order to solve. So PEMDAS, the order of operations, is how we simplify. SADMEP allows us to solve, allows us to bring everything to the other side of the equation. So you can see first, we subtracted 3 from both sides. Once we subtracted 3, we divided the 2 to the other side. That has left us now with the actual exponential by itself, and is set equal to just some number. So what we're going to look at is 4 different ways of getting the same answer for this. And the reason why we're looking at this is because everyone has a different method that they prefer. I honestly prefer the first method, which is to turn it into logarithmic form. So we have 5 to the 2x minus 3 equals 8. We know that a logarithm is the inverse of an exponential, and so to undo this exponential, I can use a logarithm put into log form. So we start with writing the word log, we look at the base, we go around to find what the argument is, we come back up to see what we're going to set it equal to. So setting it into logarithmic form. Now that I'm in logarithmic form, I am solving for x, so I can go ahead and once again use SADMEP to isolate. We're going to add 3 to both sides. Then we're going to divide both sides by 2. So we end up with x equals log base 5 of 8 plus 3 over 2. Now, sometimes you can just leave your answer like this. You can leave it in logarithmic form. But especially when we're dealing with applications, it's useful to know what this number really is. Most calculators don't do log base 5. Most calculators only do a common log, which is log base 10, we just write log, or a natural log, which we write as ln to base e. So in order to do that, I have to use what is known as the change of base formula. I have to use the change of base to make this log base 5 into either base 10 or natural log. Previously, we have said that the change of base formula, I'm going to come out here to the side, the change of base formula, ooh, not the best color, says that you can write any log, so log base b of a, you can rewrite it as a ratio of logarithms. You can choose whatever base you want, so we're just going to call that c for now. What was the argument of the original one, so is the argument on the top. What was the base of the original one becomes the argument on the bottom. So we're going to use that method here, and for our sake, we're just going to choose the common log. So that gives me x equals, and I'm going to use the change of base, so I'm going to do a ratio, log over log. What was the argument on the top of the original stays on the top. What was the base goes on the bottom. So I rewrote this logarithm as this ratio of logarithms. And I can go ahead and put the rest of the stuff on here. Now, I am going to pull out my handy-dandy calculator and type this in just to see what number we get to really show that as we go through these different examples, we're going to get the same thing. So the log of 8 divided by the log of 5 plus 3 divided by 2 gives me x equals 2.146. So this method involved switching into logarithmic form, solving for x, but then at that last step, in order to actually put in our calculator, we had to use the change of base formula. Now this one was originally labeled change of base, and it's because we're going to show how we get this same answer. You can also use common log if you're taking notes along if you want to, because that's the method we're going to do here. So if we go back to our original problem, we have 5 to the 2x minus 3 equals 8. So one of the golden rules of algebra says anything you do to one side of the equation, you have to do to the other side of the equation. We see that a lot with solving, the idea of subtracting things from both sides, adding, dividing, etc. But the other side of that is not only is it whatever you do to one side, you have to do to the other, is that you can do whatever you want to one side of the equation, and as long as you do it to the other, it's still equal. So I can add 3 to both sides if I wanted, and now they're still equivalent expressions. I could divide both sides by 12 if I wanted, and they're still equivalent expressions. We saw with radicals, we can raise both sides to a power, so I could raise both sides to be squared, and they would still be equivalent expressions. Now, none of those ones that I've done have actually helped me solve, but they've gotten me started. So, as we've learned in this unit, that's a terrible 8, as we've learned in this unit, logarithms are just another operation. So we can actually just take the log of both sides. So we're going to make these the arguments. I'm using the common log here. So as long as I take the argument, take the log of both sides, so the log of this and the log of this, they're still equivalent expressions. Well, now that I have done this, my properties of logarithms say I can move this as the exponent to make it a coefficient. So that gives me 2x minus 3 times the log of 5 equals the log of 8. In order to get this x by itself, the very first thing, because they're inside the parentheses, I need to get rid of everything that's not inside the parentheses. So I'm going to get rid of this log 5. Because it's multiplied, I'm going to divide it to their side, giving me 2x minus 3. I can get rid of those parentheses now. Is equal to the log of 8 over the log of 5. Hopefully that's starting to look familiar. Now we can just go ahead and isolate x. So 2x equals the log of 8 over the log of 5 plus 3. Divide everything by 2. If we zoom out, here you are going to notice we have exactly the same thing written here on both of them. So because we have exactly the same thing, I'm going to get exactly the same answer because in its algebraic form, they look identical. So this is why we call this the change of base, is to show you that this is really how the change of base formula works. It's kind of, you can think about why we were able to do this. And this is just showing you that another way of solving the problem will get you to the same exact spot. So here, we actually put into logarithmic form and then had to use the change of base formula to get here. For this one, we took the log of both sides, and when we solved it out, we got to something that looked like the change of base formula. So keeping this in mind, we're going to do a very, very, very similar method, but we're going to use it with the natural log. Just like we did before, we're going to take the log of both sides, but this time we're going to take the natural log of both sides. It's going to be the same process. These are LNs. I just write my L's cursive. Sometimes people think those look like an E. It is an L, I promise. Once again, if we zoom out, we're going to notice that these expressions are very, very similar. But this one was taking the common log, and this one is taking the natural log. Well, our change of base formula over here said you could choose whatever base you wanted. And so up here, same thing, when I took the log of both sides, I could take whatever base I wanted because I was doing it to both sides of the equation. And so in the end, these should still be equivalent expressions. So here, this is where I'm going to type it in my calculator. So I'm going to say the natural log of 8 divided by the natural log of 5 plus 3 divided by 2, and I got x equals 2.146. So even though we are using the natural log in this case, we still get the same answer. So many solving applications use the natural log, and so some people just like to get into the habit of using it this way to start with. because then when you get into the world of applications, it's going to be a little bit easier. The common log works too. Using in logarithmic form and then doing the change of base works. All of these methods work. It's just which one makes the most sense to you. And like I said, especially when you start getting into applications, which way you want to do it. There's one more way that I want to show you. This one is going to be similar to the ones we just did. We're going to take the log of both sides. But because the base of my exponential is 5, I'm going to make that the base of the log that I'm taking. One of my properties of logarithms says, and it's very similar, we're going to move this to the front, but this right here, log base 5 of 5 is 1. So when I move this to the front and multiply it by 1, we just get this. It is one of those properties, often you'll just see me cancel it and go ahead and circle or underline that. So when we simplify, we get 2x minus 3 equals log base 5 of 8. Notice that is exactly what we got here. Taking the log of both sides and using the base of your exponential as the base of your logarithm is just another way to convert you, to get you there. That's really how this conversion works. That's really what you're doing, is taking the log of both sides. But you can just do the rewrite, or you can do the extra step. Either way, you get to exactly the same place. Because we got to exactly the same place, that means when we solve it out, we're eventually going to get x equals log base 5 of 8 plus 3 over 2. And once again, to use this in our calculator, we would have to use the change of base. We would want to use either the common log, which we've already done, or the natural log, which we have already done. So there you have it. Here are the different ways of solving. You can either put into logarithmic form, or you can take the log of both sides. If you're taking the log of both sides, you have a few different options on what base you're going to do. This way helps you just make sure that you convert it to logarithmic form correctly. These two methods allow you to already be in that change of base formula kind of setup by the time you get to your final answer.